Hi everyone, in this video we're looking at gradients of a curve, which is essentially the whole reason why we have calculus. So if we think very quickly about a function, when we're looking at a line, it's very easy to calculate its gradient because it's simply rise over run, and because it's a straight line, that's consistent across the whole line. When we get to curves like x squared is a curve that goes like this. And so if you simply took rise over run, it's going to change depending on where you are on the curve, and so it's not consistent. And this is where calculus lets us find a gradient at a particular point. So for this example here, when we're finding the gradient function, we differentiate this. And one way to write the gradient is dy by dx, that means change in y divided by change in x. And we just differentiate x squared, so we get 2x. When we differentiate something, we can call that thing our gradient function, and if we substitute in an x value, it gives us the gradient at that point. So what we have to do to find the gradient at that point is take that value of 3 and put it into here instead of x. And so we can write m is a letter that we often use for the gradient, so we can write m equals 2 times 3, and so the gradient at that point is going to be 6. So in other words, up 6 across 1. So finding the gradient of a curve using calculus is straightforward. You simply differentiate to get your gradient function, and then from there you substitute in the x value. So substitute x value. As far as the y value is concerned, well, the function is defined in terms of x, and so the y value of 9 you don't use, it's just the x value that you need. Okay, so to practice this skill, I'd like you to go into exercise 21.01, please.